Question number 21 deals with electric potential and potential difference. What is electric potential? Suppose you have very heavy charge Q. Because of this charge, as we have covered in previous questions, there is surrounding a charge, there is a electric field where you can experience its influence, its effect. If you place a small test charge, say +1 coulomb, because of positive, it experiences, yes, repulsion, and it will move from this point to, yes, from distance r to infinity. It will move up to infinity. So, if you release it, because of repulsion, it will move from this position r to infinity. Work done by this charge as it moves from this position to infinity is termed as electric potential. It is work done per unit charge. 1. Other definition. If there is a +1 coulomb charge, unit test charge placed at infinity. Now there is a force of repulsion. I will have to do work to move it from infinity to r. Why? Because the force between the two is repulsive in nature. So work done by me to bring this charge from infinity to this point is also termed as electric potential. So what is electric potential? A unit positive test charge is placed at point P at a distance r. This point is termed as P. At a distance r. From plus Q charge Q is large and at rest. Charge at P will move from P to infinity due to force of repulsion. Work done by unit test charge as it moves from P to infinity is called potential at point P. Work to be done on the charge by external agent to move unit test charge from infinity to point P. That means there are two definitions. 1. It moves from P to infinity. And the second one is you move from infinity to this point P. Work done in both the cases comes out to be same. Example. So what is electric potential? Work done per unit positive test charge. Value is small. This is 1. As an example, if this charge moves from P to infinity and the work done is 100 joule, then electric potential at P, Vp is equal to 100 joule per coulomb. This joule per coulomb we will take it as volt. So SI unit for electric potential is what? Volt. 1 volt means what? 1 joule per coulomb. Dimensional formula. Dimensions of potential. Yes, work per unit charge. Dimensional formula for work divided by dimensional formula for charge plus 1. Dimensional formula for work is, yes, M1 L2 T minus 2. What about charge? Yes, ampere is unit for current. Ampere into time. Charge is not Q, it is ampere into time. So what you get is M1 L2. This is T minus 2. If you take it to numerator, t minus 3 is r minus 1. So dimensional formula for potential is m1 L2 t minus 3 a minus 1. Time with you is 4 minutes. B part deals with what? Potential difference. Same. Suppose there is a charge Q and there is a point P. At certain distance, say R1, and point Q at certain distance, say R2. If you place a charge, unit positive test charge, it will move from P to Q. Why? Because of repulsion. Suppose potential at P is 150 volt at this point, and potential at Q is 100 volt. What is the potential difference between the two? 50. Which of the two is at higher potential? P. It is just like a point P. It is 150 meters above floor. Another point, it is 100 meters above floor. So P is at higher level than this point Q. Let me mark this as this is charge, this is point. That is why you need to understand. We can change this. Is it R? The notes it is written as R or what? We change it because it's Q. It may lead to some confusion. R. So P is at 150, R is at 100. Difference between the two is 50 units. If water is available at this point, you release it. It will move from higher level to lower level. Water flows from higher level to lower. Charge will flow from higher potential to lower potential. So what is potential difference? Potential difference is work which a unit positive test charge will do as it moves from one point to another. As an example, potential at P, yes, how much? 150 volt. Potential at R, 100 volt. Potential difference delta V is potential at P minus potential at R is equal to 150 volt minus 100 volt is equal to what? 50 volt. So delta V potential difference is 50 volt. Point P is 50 volt higher than point R. 3 minutes with you to write. Work done. As you move from P to Q, there are options available. You move from P to Q, charge P2, sorry, R, charge moves on path 1 or on path 2 or on path 3, work done does not depend on path followed. Why? Because reason is what? Electric field is conservative. +1. Gravitation. Earth. If there is some mass at A, you move from A to D directly, work done is 100 units. This is route number 1. If you move from A to D, from A to B, B to C, C to D, if you follow this route, route number 2, the work done comes out to be same. Work done does not depend on path because gravitational field surrounding Earth is conservative and the forces involved are central. They act along the line joining centers of the two. Electric field is conservative as the forces involved are central. 1 minute with you to write. 1 minute to write.